Today we're talking about translations, and I'm going to split this up into two parts. What we're doing today is super easy. What we're doing tomorrow is not really hard, but it's a little more challenging than this one is. But it's translations. When we did that tessellation right before fall break, that was a translation tessellation, because we took the shape and we slid it all over the place, right? Okay, and the translation is also known as a slide. And it is a translation. A translation is a transformation in a plane that masks all points of a pre-image the same distance and in the same direction. So we take this pre-image, ABC, that's in black, okay, and you take and you slide it the same distance in the same direction to its image. So you take your pre-image ABC and you translate it or slide it to your image, okay? Now, this is actually called a vector. Okay, each one of these lines is a vector. A vector is a directed distance. You know what a ray is, right? A ray has an endpoint and it extends indefinitely in one direction. A vector is like a ray, except it has direction and it has length. So it starts at one point and it ends at one point. Okay? When you go on a flight, your pilot has to file a flight plan with the FAA. It says, I'm going to go from here to there. It's a vector. It's the point from here to there. Like I'm from here to Dallas. Okay? And they have to do that so they don't collide in the sky with another airplane. Okay? And so each one of these are vectors. You'll notice that each one of them are congruent. See the congruence markings? And they are also parallel. So you take and you slide it, and that distance is parallel to the others, and the distance is congruent. Okay? All right. So a translation of a triangle, you go x units along the x-axis, y units along the y-axis. And this is how they write a translation. You have a capital T, and then as a subscript, it looks like parentheses, but they're not. It's little V's that are turned sideways. Okay, that's called vector notation. So you have a little sideways V, x, comma, y, and then another sideways V going the other direction. Okay, it's not parentheses, it's not brackets, it's not braces, it's little sideways V's. Okay, to indicate a vector. So it says, and what that tells me is I'm going to take my point and I'm going to go along the x-axis, whatever this tells me to go, and I'm going to go along the y-axis, whatever that tells me to go. Okay. And then here are the properties of it. Remember I told you that from A to A prime it's going to be parallel from B to B prime, and it's parallel to C prime. And their distances are congruent to each other. You will notice that the pre-image and the image have the same orientation. Okay? The A's are in the same spot, the B's are in the same spot, and the C's are in the same spot. It's not reflected or rotated or anything like that. And it does exhibit rigid motion. Remind me what rigid motion is. It maintains length and angle measure, right? Okay. All right. So that's what it is. All right. So let's look at an example. It says find the image of a translation. This one asks us to graph it. It says translate through the vector 7, negative 4, the triangle EFG onto triangle E prime, F prime, G prime. So that means I'm going to take each point and go 7 units to the right because it's positive, and 4 units down because it's negative. Okay? So I go here and I go 1, 2, 3, 4, 5, 6, 7. That's going to be my E prime. Oh, no, I forgot to go down. 1, 2, 3, 4, 5, 6, 7, and then down 1, 2, 3, 4. Right? Negative 4. So there is E prime. And then I'm going to do the same thing with F. I'm going to go 1, 2, 3, 4, 5, 6, 7 to the right, and 1, 2, 3, 4 down. That's going to be F prime. And then G prime, I go 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3, 4. And that's G prime. And so now I have translated my pre-image through the vector 7, negative 4. 7 units to the right, 4 units down. Okay, so that's graphing. Then they might ask you just to give the vertices. So you don't necessarily have to graph it, but you can just apply the vector to it. So I'm going to write down the coordinates for E, F, and G Okay, E is located at 1, 2, 3, 4, 5 to the left, and 1, 2, 3, 4 up. So that's negative 5, positive 4. F is to the left 1, up 5. So that's negative 1, 5. And then G is to the left and down 1. So that's negative 2, negative 1. Okay, so when I translate it through the vector, I get E prime, F prime, and G prime. And so since the vector is 6, negative 7, that means I'm going to add 6 to each one of the x's and subtract 7 from each one of the y's. So I got 6 minus 5, which is 1, and negative 7 plus 4, which is negative 3. And here I've got 6 minus 1, which is 5, and negative 7 plus 5, which is negative 2. And then again I've got 6 minus 2, which is 4, and negative 7 minus 1, negative 8. All right. So, and you can graph it to test if you want it, okay? All right, so questions on what we did there? Okay. Then you might be asked to work backwards, okay? You might be asked to work backwards. So this time we want to find out what the rule is. And so you have to look to see what did they do to get from S to S prime. Yes? Negative 1 what?
They went to the left one.
They went to the left 1 and then what?
They went through the
They went down 4, right? So they went to the left 1 and down 4. So you would do a translation through, since you went to the left, it would be negative 1, and you went down, it would be negative 4. Okay? And you're mapping your x, STUV onto S prime, T prime, U prime, V. Okay. Alright, so that's coming up with the rule. Pretty simple. Here's another one. What translation rule maps P, which is negative 3, 1, to its image P prime? We're going from P to P prime. What do we do? Go left, right first. Order pair. It's like order pair. 1, 2, 3, 4. A positive 5, up 2, right? So that would be a translation through the vector. Positive 5, positive 2. So we're taking P onto P prime. Okay? So it's just moving. That's all it is. Left. The first number tells you which way to go left or right. The second number tells you which way to go up or down. Okay? Tomorrow we're going to talk about what happens when you put more than one transformation together. Okay? That's all we're going to do for today.